Beyond the algorithm, Penrose's quest for the nature of consciousness. The Emperor's New Mind. Roger Penrose's The Emperor's New Mind is a thought-provoking exploration of the relationship between computers, minds, and the laws of physics. The book argues against the possibility of strong artificial intelligence, claiming that human consciousness cannot be replicated by a computer program. Here's a breakdown of the book's main arguments. 1. The limits of computation. Penrose starts by examining the nature of computation, arguing that all computers operate on algorithms, which are essentially sets of logical rules. He then introduces the concept of a Turing machine, a theoretical model of computation that represents the fundamental limits of what computers can achieve. Penrose argues that while computers can excel at tasks like playing chess or performing mathematical calculations, they are fundamentally limited in their ability to understand and reason about complex concepts like consciousness. 2. Gödel's incompleteness theorems. Penrose highlights the significance of Gödel's incompleteness theorems, which demonstrate that within any sufficiently complex formal system, there will always be statements that are true but cannot be proven within that system. He argues that this limitation applies to computers, suggesting that they cannot fully capture the complexities of human thought, which transcends the limitations of formal systems. 3. The role of physical laws. Penrose delves into the nature of physical laws, arguing that they are not simply mathematical equations but reflect a deeper reality that cannot be fully captured by algorithms. He suggests that human consciousness, with its ability to understand and reason about abstract concepts, might be connected to this deeper level of reality, which transcends the limitations of computation. 4. The importance of quantum mechanics. Penrose proposes that quantum mechanics, with its inherent randomness and uncertainty, might play a crucial role in the emergence of consciousness. He introduces the concept of objective reduction, or suggesting that quantum events might be influenced by a deeper level of reality, leading to the emergence of consciousness. 5. The Emperor's New Mind. The book's title, The Emperor's New Mind, is a metaphor for the illusion of artificial intelligence, drawing parallels to the story of the Emperor's New Clothes, where everyone pretends to see something that doesn't exist. Penrose argues that the pursuit of strong AI is based on a misunderstanding of the nature of consciousness and the limitations of computation. 6. Beyond computation. Penrose concludes by suggesting that consciousness is a fundamentally different phenomenon than computation, requiring a deeper understanding of the universe and the laws of physics. He calls for a new kind of science, one that goes beyond the limitations of classical physics and embraces the mysteries of quantum mechanics and the nature of consciousness. Overall, The Emperor's New Mind is a challenging and thought-provoking book that raises fundamental questions about the nature of intelligence, consciousness, and the limits of computation. It is a work that has sparked debate and continues to be relevant in the ongoing discussion about the future of artificial intelligence. Let's delve deeper into some key aspects of The Emperor's New Mind and the arguments it presents. 1. Gödel's incompleteness theorems and the limits of computation. The core idea, Gödel's theorems prove that within any formal system, like a computer program, capable of doing basic arithmetic, there will always be statements that are true but cannot be proven within that system. Penrose's argument, this suggests that computers, limited by their reliance on formal systems, cannot fully capture the complexities of human thought, which seems to be able to grasp truths that lie beyond the limitations of formal systems. Analogy, imagine a computer program designed to prove all true mathematical statements. Gödel's theorems show that such a program would inevitably encounter statements it could never prove, even though they are true. This is because the program is bound by its own internal rules, which cannot encompass all possible truths. 2. Objective reduction, and the role of quantum mechanics. The problem, Penrose argues that classical physics, with its deterministic laws, cannot explain the emergence of consciousness. He believes that consciousness requires a level of randomness and unpredictability that classical physics cannot provide. Penrose's solution, he proposes that quantum mechanics, with its inherent randomness and uncertainty, might hold the key. He introduces the concept of objective reduction, suggesting that quantum events might be influenced by a deeper level of reality, leading to the emergence of consciousness. Or in a nutshell, quantum systems are governed by superposition, a state where they exist in multiple possibilities simultaneously. Or proposes that certain quantum events, when they collapse into a single outcome, are influenced by a deeper level of reality beyond the standard quantum description. This deeper level, according to Penrose, could be the source of consciousness. 3. The Emperor's New Mind, a metaphor for the illusion of strong AI. The story, The Emperor's New Clothes, is a classic tale where everyone pretends to see beautiful clothes on the emperor, even though he is actually naked. This is because they are afraid to admit they cannot see the clothes, fearing they will be seen as foolish. Penrose's analogy, he argues that the pursuit of strong AI is similar. People are so convinced that computers will eventually achieve human-level consciousness that they are willing to ignore the fundamental limitations of computation. The message: Penrose warns against the dangers of fashion, faith, and fantasy in science, urging us to be critical and to question assumptions, even those that are widely accepted. 4. Beyond computation, a call for a new science. The need for a new approach. Penrose argues that the current understanding of physics, particularly classical physics, is insufficient to explain consciousness. The call for a new science: he calls for a new kind of science, one that goes beyond the limitations of classical physics and embraces the mysteries of quantum mechanics and the nature of consciousness. This new science would need to explore the deeper levels of reality that might be responsible for the emergence of consciousness. The Emperor's New Mind is a complex and challenging book that raises profound questions about the nature of consciousness and the limits of computation. It is a work that has sparked debate and continues to be relevant in the ongoing discussion about the future of artificial intelligence. Penrose's theory of objective reduction, or, directly addresses the limitations of classical physics in explaining consciousness. Here's how. 1. The problem with classical physics. Deterministic nature. Classical physics is deterministic, meaning that if you know the initial conditions of a system, you can predict its future behavior with complete accuracy. This deterministic nature clashes with the apparent randomness and unpredictability of consciousness. Lack of a role for randomness. Classical physics doesn't provide a mechanism for incorporating randomness or uncertainty, which seem essential for the subjective and creative aspects of human experience. The hard problem of consciousness. The hard problem of consciousness refers to the difficulty of explaining how subjective experience arises from the physical processes of the brain. Classical physics, with its deterministic nature, seems ill-equipped to address this problem. 2. Penrose's solution: objective reduction, or quantum mechanics as a potential solution. Penrose argues that quantum mechanics, with its inherent randomness and uncertainty, might hold the key to understanding consciousness. Or as a bridge between quantum and classical, or proposes that certain quantum events, when they collapse into a single outcome, are influenced by a deeper level of reality beyond the standard quantum description. This deeper level, according to Penrose, could be the source of consciousness. Or in the hard problem, by introducing a non-deterministic element into the quantum realm, or potentially provides a mechanism for bridging the gap between the physical processes of the brain and the subjective experience of consciousness. 3. Key points. Classical physics is deterministic and lacks a mechanism for randomness, making it difficult to explain consciousness. Or proposes that quantum events can be influenced by a deeper level of reality, potentially providing a link between the physical and the subjective. Or is a controversial theory, but it highlights the limitations of classical physics in explaining consciousness and the potential role of quantum mechanics. In essence, Penrose's theory of objective reduction attempts to address the limitations of classical physics by proposing a mechanism for incorporating randomness and uncertainty into the quantum realm, potentially providing a bridge between the physical and the subjective, and offering a possible explanation for the emergence of consciousness. Penrose's theory, while intriguing, has faced criticism for its lack of concrete experimental predictions. However, it does offer a few potential avenues for testing its validity. 1. Quantum effects in the brain. Prediction, or suggests that quantum effects are not just confined to the microscopic world but could play a significant role in macroscopic systems like the brain, specifically in the emergence of consciousness. Testing, this could be investigated by searching for evidence of quantum phenomena like entanglement or superposition in brain activity. Challenges, the brain is a complex and noisy environment, making it incredibly difficult to isolate and measure quantum effects. 2. Specific quantum events linked to consciousness. Prediction, or suggests that specific quantum events, like the collapse of a superposition, could be linked to conscious experiences. Testing, this could involve trying to correlate specific brain activity patterns with conscious events, searching for evidence of quantum collapse during moments of conscious awareness. Challenges, identifying the specific quantum events and correlating them with conscious experiences is extremely challenging. 3. Effects of gravity on consciousness. Prediction, Penrose's theory suggests that gravity plays a role in influencing the collapse of quantum states. Testing, this could involve studying the effects of gravitational fields on brain activity and consciousness. For example, experiments could be conducted in microgravity environments or using strong magnetic fields to manipulate the gravitational environment. Challenges, Conducting such experiments with human subjects is ethically and practically difficult, and the effects of gravity on consciousness are likely to be subtle and difficult to measure. 4. Computational limits of artificial intelligence. Prediction: if or is correct, computers, limited by their reliance on classical computation, would never be able to achieve true consciousness. Testing: this could be tested by observing the limitations of AI systems in tasks that require genuine understanding and creativity, such as artistic expression, philosophical reasoning, or moral decision-making. Challenges: defining and measuring true consciousness in AI systems is a complex and controversial issue, making it difficult to definitively test this prediction. Overall, while Penrose's theory offers a potential framework for understanding consciousness, it currently lacks robust experimental predictions that can be easily tested. The challenges of isolating and measuring quantum effects in the brain, correlating specific quantum events with conscious experiences, and studying the effects of gravity on consciousness make it difficult to definitively prove or disprove the theory. However, ongoing research in quantum biology and neuroscience, combined with advances in AI and our understanding of consciousness, might eventually provide the tools and techniques needed to test the validity of Penrose's intriguing theory. Penrose's arguments against strong AI have significant philosophical implications, challenging our understanding of 1. The nature of consciousness. Dualism versus materialism. Penrose's arguments lean towards a dualistic view of consciousness, suggesting that it is not simply a product of the physical brain but involves a deeper, non-computable element. This challenges the prevailing materialist view, which posits that consciousness is entirely reducible to physical processes. The role of subjectivity. Penrose emphasizes the subjective nature of consciousness, arguing that it cannot be fully captured by objective, third-person descriptions. This highlights the importance of subjective experience and the limitations of purely objective scientific methods in understanding consciousness. 2. The limits of computation. The computational model of mind. Penrose's arguments challenge the idea that the mind can be fully modeled as a computational system. This raises questions about the adequacy of computational models for understanding complex cognitive phenomena like creativity, intuition, and moral reasoning. The limits of artificial intelligence. Penrose's arguments suggest that strong AI, which aims to replicate human-level intelligence in machines, might be fundamentally impossible. This raises ethical and philosophical questions about the nature of intelligence, the potential risks of advanced AI, and the implications for our understanding of ourselves. 3. The relationship between mind and matter. Emergentism versus reductionism. Penrose's arguments lean towards an emergentist view of consciousness, suggesting that it arises from but is not reducible to the physical brain. This challenges the reductionist view, which posits that all phenomena can be explained in terms of their underlying physical constituents. The role of quantum mechanics. Penrose's proposal of objective reduction suggests that quantum mechanics might play a crucial role in the emergence of consciousness, linking the mind to the fundamental laws of physics in a way that goes beyond traditional materialist explanations. 4. The nature of reality. The deeper reality of consciousness. Penrose's arguments suggest that consciousness might be connected to a deeper level of reality that transcends the limitations of computation and classical physics. This raises questions about the nature of reality, the existence of non-computable phenomena, and the possibility of a deeper understanding of the universe. The limits of science. Penrose's arguments highlight the limitations of scientific methods in fully understanding consciousness, suggesting that there might be aspects of reality that are inherently beyond the reach of scientific inquiry. Overall, Penrose's arguments against strong AI have profound philosophical implications, challenging our understanding of consciousness, computation, the relationship between mind and matter, and the nature of reality itself. His work encourages us to re-examine our assumptions about the nature of intelligence and the limits of our current scientific understanding. Penrose's vision for a new kind of science that goes beyond classical physics is deeply intertwined with his ideas about consciousness and the limitations of computation. He argues that the current scientific framework, based on classical physics and its deterministic laws, is insufficient to explain the full complexity of the universe, particularly when it comes to the emergence of consciousness. Here's a breakdown of his proposed new kind of science. 1. Incorporating quantum mechanics. Penrose believes that quantum mechanics, with its inherent randomness and uncertainty, holds the key to understanding consciousness. He criticizes the traditional interpretation of quantum mechanics, which suggests that the randomness arises from our limited knowledge of the system. Instead, he proposes that quantum events are truly random and might be influenced by a deeper level of reality, a non-computable realm that transcends the limitations of classical physics. 2. Objective reduction, or Penrose introduces the concept of objective reduction, or, to explain how quantum events might lead to the emergence of consciousness. He suggests that quantum systems, when subjected to certain conditions, can undergo a spontaneous collapse, or reduction, of their wave function, leading to a definite outcome. This collapse, he argues, is not merely a result of observation but a fundamental aspect of reality, influenced by a deeper level of physics that we don't fully understand. 3. The role of gravity. Penrose believes that gravity, the force that governs the large-scale structure of the universe, might play a crucial role in this objective reduction process. He suggests that the interaction between quantum systems and the gravitational field could lead to a collapse of the wave function, potentially influencing the emergence of consciousness. 4. A deeper level of reality. Penrose argues that this deeper level of reality, which influences quantum events and potentially gives rise to consciousness, is fundamentally non-computable. This means that it cannot be fully captured by algorithms or simulated by computers. He believes that this non-computable aspect of reality is essential for understanding the nature of consciousness and the limitations of artificial intelligence. 5. The need for new theories. Penrose calls for the development of new theories and frameworks that go beyond the limitations of classical physics and embrace the complexities of quantum mechanics and the potential role of gravity in consciousness. He believes that such a new kind of science would require a deeper understanding of the universe and its fundamental laws, potentially leading to a revolution in our understanding of consciousness and the nature of reality. In essence, Penrose's proposed new kind of science is a call for a paradigm shift in our understanding of the universe, one that acknowledges the limitations of classical physics and embraces the mysteries of quantum mechanics and the potential role of gravity in shaping the emergence of consciousness.